Have you ever looked up at the night sky and felt a shiver of wonder, that tug in your chest when you realize just how little we truly understand about the vast, glittering darkness above us? The universe is full of secret, strange, breathtaking phenomena that defy everything we think we know. Just last year, astronomers detected a mysterious radio signal from deep space, pulsing with a rhythm that shouldn't exist. No one could explain it, and that's just the tip of the cosmic iceberg. From stars that vanish without a trace to galaxies that spin faster than physics allows, the cosmos is teeming with anomalies that leave even the brightest scientists utterly stumped. That's exactly what we're diving into today, 25 of the most jaw-dropping cosmic anomalies ever discovered. These aren't just quirks of space, they're full-blown mysteries that rewrite the rules of reality. Picture a black hole that shoots out gargantuan jets of energy with no clear source, or a planet that somehow glows hotter than the star it orbits. These aren't sci-fi plot twists, they're real, documented events happening right now, light years away, challenging our understanding of the universe itself. So why do these cosmic head-scratchers matter? Because every time we stumble upon one, it's like the universe is handing us a puzzle piece, one that might just reveal a bigger picture we've never seen before. Whether it's a flickering star that hints at alien megastructures or a void in space so empty it shouldn't exist, each anomaly pulls us deeper into the greatest detective story of all time. And you're invited along for the ride, so buckle up, we're about to explore the unexplainable, the bizarre, and the downright eerie wonders that lurk in the farthest reaches of space. Trust me, by the end, you'll never look at the night sky the same way again. Back in 1977, a radio telescope in Ohio picked up something that still sends chills down astronomers' spines. A blast of radio waves so powerful and peculiar that the scientist who discovered it scrawled, "Wow," right on the printout, and that's exactly what it was. For 72 blistering seconds, this mysterious signal blared from deep space near the constellation Sagittarius, hitting a frequency that scientists had long suspected might be used by extraterrestrial civilizations. Then, just as suddenly as it appeared, it vanished, poof, gone without a trace. Despite decades of searching, we've never heard anything like it again. So what made the wow signal so spine-tingling? First, its intensity, 30 times stronger than the cosmic background noise. Then there's the frequency, 1420 MHz, smack in the so-called water hole, a quiet band between hydrogen and hydroxyl radio waves that's perfect for interstellar communication. Even stranger, the signal's narrowband pattern, something natural cosmic phenomena rarely produce. It looked artificial, engineered. Scientists have thrown every possible explanation at it: comets, pulsars, even a rogue satellite. But none fit perfectly. The leading natural theory points to hydrogen clouds around a pair of comets that happen to be passing through that exact patch of sky. Except those comets weren't discovered until decades later, and their radio emissions don't match the wow signal's bizarre profile. Then there's the extraterrestrial possibility. Could this have been a fleeting hello from another civilization, a distress call, or just a cosmic blip we'll never fully understand? What keeps astronomers up at night is how precise and fleeting it was. Imagine shouting into the void and getting one crystal clear reply, followed by eternal silence. The wow signal is like a single fingerprint on a cosmic crime scene. No body, no weapon, just the tantalizing hint that something extraordinary happened. And until we catch another one, it remains the universe's most maddening unanswered call. The night sky is sprinkled with hundreds of billions of galaxies, each containing countless stars, so many that the odds of Earth being the only planet with intelligent life seem astronomically slim. And yet, silence, no signals, no visitors, not even a single blip on our radar suggesting we're not alone. This eerie contradiction has a name: the Fermi Paradox. Named after physicist Enrico Fermi, who famously asked, "Where is everybody?" It's one of the most unsettling mysteries in science. If the universe is so vast and ancient, why does it feel so empty? One chilling explanation is the Great Filter, a theoretical barrier that prevents life from advancing to interstellar communication or exploration, the terrifying part. We don't know if we've already passed it, like being the only seed to sprout in a barren field, or if it's still ahead of us, lurking in humanity's future. Maybe civilizations inevitably wipe themselves out with war or climate collapse before they can reach the stars. Or perhaps something far darker awaits, a cosmic bottleneck we can't yet imagine. Other theories are equally mind-bending. Some suggest advanced civilizations might avoid detection on purpose, hiding from potential threats. Others propose that intelligent life is rarer than we think, snuffed out by gamma-ray bursts or rogue planets before it can flourish. Then there's the zoo hypothesis, the idea that Earth is intentionally quarantined, observed like an exhibit in some unimaginable galactic sanctuary, but the most haunting possibility. That we truly are alone, that in all this endless space, against all probability, life only sparked once, a single flicker of consciousness in an infinite, indifferent void. The Fermi Paradox doesn't just question the existence of aliens, it holds up a mirror to humanity's own fragility. Are we destined to fade into silence, just another unanswered echo in the dark? Or is something out there, waiting for us to take our next step into the cosmos? The universe isn't just hiding its secrets, it's forcing us to confront our place in them. Imagine holding a snow globe, except when you shake it, the glitter inside stays perfectly still. That's the unsettling puzzle of dark matter. We can't see it, touch it, or even detect it directly, yet we know it's there because the universe behaves as if it's filled with something invisible. Galaxies spin too fast to hold themselves together. Light bends around cosmic voids where nothing visible exists. Entire clusters of galaxies move as if tugged by unseen hands. The math doesn't lie. Roughly 27% of the universe is made of this ghostly substance, outnumbering ordinary matter 5-1. And after decades of searching, we still don't know what it actually is. Here's what makes dark matter so baffling. Unlike black holes or distant planets, it doesn't emit, absorb, or reflect light, hence the name. It doesn't interact with electromagnetic forces at all. The only clue we have is gravity. Take the Bullet Cluster, for example. Two galaxies collided, and their visible gas clouds smashed together like fog, while their dark matter components sailed right through each other, detected only by how they warped the light from stars behind them. It's like watching footprints appear in fresh snow with no one walking there. Scientists have proposed wild theories to explain it. Could dark matter be made of weakly interacting massive particles that barely touch ordinary matter except through gravity, or actions, hypothetical particles so light they flutter through walls like cosmic dust? Experiments deep underground, in abandoned mines and mountain tunnels, hunt for these elusive particles using vats of liquid xenon or ultra-sensitive crystals. So far, silence. Some researchers even suggest we've got gravity all wrong, that dark matter doesn't exist, and instead our equations need a radical rewrite. But every tweak to Einstein's theories creates new problems without solving the mystery. The stakes couldn't be higher. Dark matter isn't just some cosmic decoration, it's the scaffolding of the universe. Without its gravitational glue, galaxies would have flown apart eons ago. Its distribution shaped the cosmic web, the vast filamentary structures where galaxies cluster like beads on a string. And if we ever do capture a dark matter particle, it could unlock entirely new physics, revealing hidden layers of reality. Until then, we're left staring at the cosmos, knowing most of it is hiding in plain sight, a universe within the universe just beyond our grasp. If dark matter is the invisible glue holding galaxies together, dark energy is the shadowy hand tearing the entire universe apart. Picture this: the cosmos isn't just expanding, it's accelerating, as if some unseen force is pressing down on the gas pedal of reality itself. And just like dark matter, we can't see it, touch it, or even detect it directly, yet its fingerprints are everywhere, etched into the very fabric of space-time. The discovery of dark energy was a cosmic shockwave. In the late 1990s, astronomers studying distant supernova made a spine-tingling realization: these exploding stars were dimmer than they should have been. The only explanation: the space between us and them was stretching faster over time, as if the universe had hit puberty and started sprinting. This wasn't just expansion, it was runaway expansion. And the culprit, a mysterious repulsive force making up a staggering 68% of the universe's energy budget. What makes dark energy so unnerving is how little we understand it. Einstein once proposed a cosmological constant, a sort of anti-gravity that kept the universe static. He later called it his biggest blunder, but now it's back with a vengeance as the leading theory for dark energy, a property of empty space itself, pushing galaxies apart ever faster. But here's the twist: if dark energy's strength increases over time, it could lead to a big rip, where even atoms are torn apart in a cosmic crescendo of nothingness. Yet competing theories abound. Some suggest dark energy isn't constant but fluctuates, tied to undiscovered fields or particles. Others propose it's a sign we're missing something fundamental about gravity, that Einstein's equations, flawless on cosmic scales, might need revision. The truth: we're groping in the dark, literally. Every telescope, every satellite, every supercomputer simulation is hunting for answers, but dark energy remains the ultimate cosmic wildcard. One thing's certain: this isn't just academic curiosity. Dark energy decides the universe's fate. Will expansion slow, reverse into a big crunch, or rip reality to shreds? It's the ultimate countdown clock, and we're only just learning how to read it. Somewhere out there, hidden behind the thick dust clouds of our own galaxy, an invisible force is tugging at the Milky Way with the strength of 1,000,000 suns. Astronomers call it the Great Attractor, a gravitational anomaly so powerful it's dragging entire galaxies, including ours, toward a mysterious point in space we can't even see. Picture the universe as a rushing river, and every galaxy within hundreds of millions of light-years is being swept toward a cosmic waterfall we've yet to map. The story begins in the 1970s when scientists noticed something bizarre about the Milky Way's motion. Even after accounting for the expansion of the universe, our galaxy, and every galaxy near us, was hurtling toward a specific patch of sky near the constellations Centaurus and Hydra at over 2 million kilometers per hour. The problem: that exact region lies behind the zone of avoidance, an area of space obscured by our own galaxy's dusty belly. It's like trying to find a lighthouse while standing in a fog bank. For decades, the Great Attractor was a cosmic ghost detectable only by its gravitational fingerprints. Early theories suggested it might be a supercluster of galaxies, an unimaginably dense knot of matter with the collective pull to bend the paths of galaxies around it. Then, in 2005, X-ray telescopes pierced the dust veil, revealing the Norma cluster, a massive gathering of galaxies about 250 million light-years away. But here's the twist: this cluster alone wasn't nearly heavy enough to explain the staggering pull. So what's really lurking in the shadows? Some researchers point to the even larger Laniakea supercluster, a galactic filament that includes the Milky Way, stretching 500 million light-years across. In this model, the Great Attractor isn't a single object but the gravitational center of our cosmic neighborhood, a sort of space-time whirlpool where galaxies naturally flow. Others speculate about more exotic possibilities: an ancient collision between universes in the multiverse, a concentration of dark matter so dense it warps reality itself, or even a remnant of the Big Bang's primordial energy. The most unsettling part: we might be missing the bigger picture entirely. recent studies suggest the Great Attractor itself could be getting pulled towards something even more massive, a structure nicknamed the Shapley Attractor, 800 million light-years beyond. It's a cosmic matryoshka doll of mysteries, each layer deeper and stranger than the last, until we develop telescopes that can peer through the Milky Way's dust without distortion. The true nature of this gravitational siren song will remain one of the universe's most compelling unsolved riddles. One thing's certain, whatever's pulling us, it's a reminder that even the grandest structures in space can hide in plain sight. In the constellation Cygnus, about 1,400 light-years from Earth, a star named KSE 8462852, better known as Tabby's star, has been flickering like a cosmic candle in the wind. But here's the thing, stars don't just dim erratically, they follow patterns. Yet Tabby's star drops in brightness by up to 22% at random intervals, sometimes for days, other times for weeks, with no clear rhythm or reason. It's as if something enormous and unpredictable is passing in front of it. And when astronomers first saw this data from the Kepler Space Telescope, one hypothesis sent shockwaves through the scientific community. Could this be evidence of alien megastructures? The idea isn't as far-fetched as it sounds. In the 1960s, physicist Freeman Dyson theorized that advanced civilizations might build vast energy-collecting structures around their stars, swarms of solar panels, or even enormous rings known as Dyson spheres. Tabby's star's bizarre dimming seemed to fit. The dips in light were too dramatic for planets, too irregular for comets, and too uneven for dust clouds. For a brief, thrilling moment, it felt like we might have stumbled onto the signature of an alien engineering project, but science thrives on skepticism. Other explanations emerged. Maybe a shattered planet or a colossal asteroid belt was casting fragmented shadows. Perhaps the star was surrounded by a swirling storm of debris left over from a cosmic collision, like Saturn's rings on a catastrophic scale. Some researchers pointed to the star's own behavior, unusually intense bursts of magnetic activity or internal instabilities that could warp its light output. Yet every natural theory has holes. Dust should glow in infrared, but Tabby's star doesn't. Planetary debris would likely follow predictable orbits, but the dimming remains stubbornly chaotic. The most compelling twist, Tabby's star isn't just dimming, it's also gradually getting darker over time. Between 1890 and 1989, its brightness dipped by 14%. That's like watching a 100-watt bulb fade to 86 watts over a century, something stars of its type simply don't do without a spectacular reason. So where does that leave us? The alien megastructure theory, while tantalizing, remains a last resort. Science demands rigor, and extraordinary claims require extraordinary evidence. But the real wonder of Tabby's star isn't just the mystery, it's how it's forced us to rethink what's possible. Whether it's a swarm of comets, a dying planet's funeral shroud, or something beyond our current understanding, this star reminds us that the universe is always one step ahead, ready to surprise us when we think we've got it all figured out. And that's what makes it one of the most captivating cosmic puzzles of our time. One moment, space is silent, then, in a fraction of a blink, a burst of radio waves brighter than a billion suns erupts across the cosmos, vanishing before anyone can trace its source. These are fast radio bursts, or FRB, some of the most enigmatic and violent events in the universe. Lasting just milliseconds, they pack more energy than our sun emits in 80 years, yet their origins remain one of astrophysics' most stubborn puzzles. What could possibly unleash such a cataclysmic flash, and why do some of them repeat like cosmic Morse code? The first FRB was discovered in 2007, hidden in old radio telescope data, a single spike of energy so bizarre, astronomers initially dismissed it as telescope interference. But then more were found, scattered randomly across the sky. The strangest breakthrough came in 2016, when scientists detected FRB 121102, the first repeating burst. Unlike its one-time cousins, this one fired off multiple blasts from the same location, a tiny galaxy 3 billion light-years away. Suddenly, the leading theories, cataclysmic explosions like colliding neutron stars, didn't fit. Whatever produced these signals wasn't destroying itself, it was persisting. So what's behind these cosmic firecrackers? Highly magnetized neutron stars are a prime suspect. These stellar corpses have magnetic fields so intense they could power starquakes, ripping open their crusts and unleashing titanic radio waves. In 2020, an FRB was traced to a magnetar in our own galaxy, adding weight to the idea. But not all FRBs match this profile. Some are too energetic, others too structured. The repeating bursts with their precise intervals hint at orbital mechanisms, perhaps a neutron star dancing around a black hole, its magnetic field twisted into a cosmic slingshot with each pass. Then there's the wild card, extraterrestrial origins. While most scientists consider this a last resort, the repeating FRBs patterns have sparked curiosity. Could they be engineered alien propulsion systems, communication attempts, or even leakage from some unimaginable technology? The truth is, we're still grasping at cosmic straws. Each new detection deepens the mystery. Some FRBs flicker with sub-millisecond spikes, suggesting structures smaller than a city. Others arrive with a telltale smear, their waves stretched by intergalactic plasma, revealing how much material they've traversed. What makes FRBs so thrilling is their duality. They're both cosmic enigmas and invaluable tools. By analyzing how these waves distort as they cross the universe, scientists can map the invisible matter between galaxies. It's like turning static into a sonar ping for the cosmos, yet every answer leads to new questions. Why do some FRBs come in pairs? What causes the rare active phases, where a source suddenly erupts dozens of times in days? And could there be entirely new physics at play? Something beyond neutron stars and black holes? For now, fast radio bursts remain the universe's most cryptic postcards, brief and brilliant, carrying secrets we've only begun to decode. Each one is a reminder that even in the silent vastness of space, there are voices shouting, whispering, repeating, waiting for us to learn their language. In the deepest maps of the infant universe, there's a pattern that shouldn't exist, a ghostly axis etched into the afterglow of the Big Bang itself. Scientists call it the axis of evil, not for any malevolence, but because its existence threatens to unravel cosmology's most cherished assumptions. Here's the spine-chilling mystery. When we examine the cosmic microwave background, the faint echo of the universe's birth, its temperature fluctuations appear strangely aligned with the plane of our solar system. It's as if the universe's blueprint knows where Earth is, violating a fundamental principle that the cosmos should look the same in all directions. This anomaly first surfaced in 2005, when NASA WMAP satellite delivered the most precise CMB map ever. Researchers expected randomness, tiny hotspots and cold spots scattered like cosmic confetti. Instead, they found a bizarre correlation. These fluctuations seem to cluster along an invisible line that eerily matches our solar system's ecliptic. The odds of this happening by chance, less than 1 in 1,000. Subsequent data from the Planck satellite only deepen the puzzle. If the universe is truly isotropic uniform, no matter where you stand, why does its oldest light appear to whisper our address? Skeptics argue it's a cosmic coincidence, a trick of statistics or measurement bias. After all, when you stare at enough random noise, even chaos can start to look like a pattern. But the axis of evil won't be dismissed so easily. The alignment persists across multiple datasets, and alternative analysis methods keep pointing back to the same unsettling correlation. Some theorists propose radical explanations. Could our solar system's motion be imprinting on the CMB through some unknown physics? Or worse, is this a sign that the Big Bang theory needs a rewrite, the most mind-bending possibility? That we're seeing evidence of a pre-Big Bang universe, a structure or influence that predates our cosmic dawn? leaving fingerprints in the CMB like shadows from another dimension. Others suggest it hints at a universe far stranger than we imagined, where the laws of physics vary subtly across space, making our corner uniquely special. The very idea sends shivers down the spine of modern cosmology, built on Copernicus's principle that Earth holds no privileged place in the cosmos. For now, the axis of evil remains a celestial riddle, one that challenges our deepest assumptions about reality. Is it a flaw in our models, a quirk of perception, or a cosmic clue pointing to truths we've yet to grasp? Either way, it's a humbling reminder that the universe might still be keeping its greatest secrets close, even in the oldest light we can see. Imagine a bubble in the universe so vast it could swallow thousands of galaxies whole, except there's almost nothing inside. This is the Boötes Void, a cosmic desert stretching 330 million light-years across, where the night sky would appear eerily black to any hypothetical observer. Discovered in the 1980s, this colossal emptiness isn't just a gap between galaxies, it's a staggering absence of them. While typical voids in space measure around 100 million light-years, the Boötes Void is so disproportionately large that it defies our understanding of how the universe structures itself. So how does something this empty even exist? The leading theory points to the cosmic web, the filamentary scaffolding of dark matter and gas that shapes the distribution of galaxies. Most voids form where these filaments stretch thin, like the hollows in a sponge. But the Boötes Void is different. It's not just thin, it's a near-total vacancy. One explanation suggests it might be the result of multiple smaller voids merging over billions of years, like soap bubbles collapsing into one enormous emptiness. Another chilling possibility, that it's evidence of an ancient collision with another universe in the multiverse, a cosmic bruise left by something beyond our reality. What's truly baffling is what isn't there. Based on the average density of the universe, the Boötes Void should contain around 2,000 galaxies. Instead, astronomers have found only 60, drifting like lonely ships in an ocean of nothingness. These surviving galaxies are clustered into a narrow tube near the void's edge, as if huddling together for warmth. Their very existence raises questions. Did they form differently, resistant to whatever emptied the void? Or are they latecomers, somehow migrating into this cosmic ghost town? The implications ripple far beyond curiosity. Voids like Boötes challenge our models of galaxy formation, suggesting that dark energy's repulsive force might work unevenly, pushing matter into denser regions while leaving others barren. They also serve as natural laboratories for studying the elusive nature of dark matter. Its gravity should leave subtle fingerprints in the void's structure. But perhaps most haunting is the void's silence. If intelligent life exists in one of those 60 isolated galaxies, their night sky would be nearly starless, their cosmic neighborhood a crushing expanse of nothing. A reminder that the universe isn't just stranger than we imagine, it's stranger than we can imagine. The Boötes Void isn't just an absence, it's a mirror held up to our ignorance. Every time we peer into its depths, we're forced to confront how little we understand about the forces that sculpt the cosmos. And that's what makes it one of the most profound mysteries in the universe, not for what it contains, but for what it doesn't. In the vast, silent expanse beyond Neptune, two robotic explorers, Pioneer 10 and Pioneer 11, were quietly rewriting the rules of physics, or so it seemed. Launched in the early 1970s, these trailblazing spacecraft completed their missions to Jupiter and Saturn, then kept going, becoming humanity's first emissaries on an endless journey into interstellar space. But as they drifted farther from the sun, scientists noticed something bizarre. Both probes were slowing down ever so slightly, as if an invisible hand was tugging them backward. This tiny but persistent deviation became known as the Pioneer Anomaly, and for decades it haunted the edges of our understanding. At first glance, the numbers didn't make sense. The pioneers were experiencing an unaccounted-for deceleration of about 8.74 times 10 to the negative 10 meters per second, squared, a whisper of resistance, but one that grew more puzzling the longer it persisted. By the time the probes reached the outer solar system, this phantom drag had nudged them off course by hundreds of thousands of kilometers. Theories erupted like solar flares. Could it be dark matter's gravitational pull, a flaw in Einstein's theory of general relativity, or perhaps an undiscovered planet lurking in the icy darkness? Then came the mundane truth: heat, not some exotic cosmic force, but the simple infrared glow of the probe's own electronics and plutonium power sources. As the pioneers radiated heat unevenly, primarily from their rear-facing equipment panels, the photons carried away momentum, creating a tiny but measurable push against their direction of travel. It was like trying to coast a bicycle downhill while holding a flashlight pointed backward. The light itself exerted a faint, relentless brake. The real lesson of the pioneer anomaly wasn't about hidden forces or new physics, it was about humility. Even our most precise instruments can be fooled by the subtle interplay of known phenomena. Future missions like New Horizons now account for this thermal recoil effect with meticulous precision. Yet the story lingers as a cautionary tale. Sometimes the universe's greatest mysteries aren't cosmic revelations, but reminders of how much we still have to learn about our own backyard. And in that sense, the pioneers' unexpected detour became one of their most valuable discoveries, not of what's out there, but of how carefully we need to watch our step. For decades, rumors have swirled about an ancient alien satellite silently circling Earth, a shadowy object dubbed the Black Knight. Some claim it's been orbiting for 13,000 years, broadcasting signals before human civilization even began. Others insist it's proof of extraterrestrial surveillance, a relic from a lost interstellar visitor. The legend is intoxicating, but like so many cosmic mysteries, the truth is buried under layers of myths, misinterpretations, and some very real space oddities. The story truly took off in 1954 when newspapers reported that the U.S. Air Force had detected two mysterious satellites orbiting Earth, impossible at the time, since no country had launched one yet. By the 1960s, amateur radio operators claimed to intercept strange signals they attributed to the Black Knight, and a blurry photograph from a 1998 space shuttle mission fueled fresh speculation. The image appeared to show a dark, jagged object floating against Earth's curvature, undeniable proof to believers. But here's where science steps in. Satellite trackers and astronomers have debunked the myth repeatedly. The 1954 detection was likely misreported research on natural radio emissions. The infamous space shuttle photo, a thermal blanket lost during an earlier mission, crumpled and drifting. As for the radio signals, they match known frequencies used by earthly satellites or even auroral phenomena. The Black Knight's legend persists because it stitches together unrelated events into a compelling narrative, one that ignores the mundane reality of space debris. Yet the debris itself tells a fascinating story. Over 20,000 human-made objects currently orbit Earth, from dead satellites to discarded rocket stages. Some, like the nearly 60-year-old Vanguard one, have outlasted their missions by decades, silently tumbling through the void. In a way, the Black Knight myth mirrors our own anxieties about what might be watching from above, not aliens, but the very real legacy of our own spacefaring era. So why does this myth endure? Because space is vast and mysterious, and sometimes the human mind would rather invent cosmic watchers than accept the eerie silence of the void. The Black Knight isn't an alien artifact, it's a Rorschach test, reflecting our deepest hopes and fears about what might lurk just beyond the edge of our atmosphere. And that, in its own way, is just as intriguing as any sci-fi plot. The moon, our closest celestial neighbor, has always been a world of contradictions, barren yet beautiful, familiar yet full of surprises. One of its most baffling quirks lies in the very rocks brought back by Apollo astronauts. Some of them are magnetic. This shouldn't be possible. Unlike Earth, the Moon doesn't have a global magnetic field today, nor does it have the churning molten core needed to generate one. So how did these rocks become magnetized, as if they'd cooled in the presence of a planetary-scale force field? The answer might rewrite what we know about the Moon's fiery youth. When scientists first analyzed lunar samples in the 1970s, they expected to find a quiet, geologically dead world. Instead, they discovered minerals locked in strange magnetic alignments, suggesting they'd formed in a magnetic environment stronger than Earth's current field. The leading theory, between 4 and 3 billion years ago, the Moon's core might have hosted a short-lived dynamo, a swirling ocean of molten metal that briefly generated a magnetic shield. Computer simulations show this could have happened if the Moon's core was heated unevenly by Earth's gravity during its closer, more turbulent orbit. Like a cosmic battery, this dynamo would have sputtered to life, then faded as the Moon cooled and drifted away. But there's a twist. Some younger moon rocks formed long after this dynamo should have died still show traces of magnetization. This has sparked wilder theories like transient magnetic fields generated by colossal asteroid impact. When a massive object slams into the Moon, the sheer energy could vaporize rock into an electrically conductive plasma, creating a temporary magnetic bubble as it expands. Think of it like rubbing a balloon on your hair, but on a planetary scale. These impact dynamos might explain why even relatively fresh lunar craters have magnetic footprints. Then there's the wild card, the Sun. During the Moon's early days, our young star was a tempestuous toddler, blasting out solar winds with far more intensity than today. Some researchers suggest these particles, interacting with the Moon's crust, could have induced localized magnetic fields like static electricity clinging to a comb. The mystery isn't just academic. If the Moon once had a dynamo, it means its core was far more active than we thought, potentially fueling volcanic eruptions that painted its surface with vast lava plains. And if impacts can magnetize rock, it changes how we interpret magnetic traces on other airless worlds, from Mercury to asteroids. Every new lunar sample, every revisited Apollo dataset brings us closer to solving this puzzle, one that turns our silent neighbor into a vault of cosmic secrets waiting to be unlocked. In October 2017, astronomers spotted something that had never been seen before, a visitor from another star system streaking through our solar system at breakneck speed. They named it Oumuamua, Hawaiian for scout, and from the moment it appeared, this cosmic interloper defied every expectation. Here was an object shaped like a pancake or a cigar, tumbling end over end, with no visible tail of gas or dust like a typical comet. But the real shock came when telescopes tracked its trajectory. Oumuamua was accelerating as if propelled by some unseen force. Theories erupted like solar flares. The most grounded explanation: Oumuamua might be a hydrogen iceberg, a chunk of frozen hydrogen gas sublimating in the sun's warmth, giving it a gentle push without leaving a visible trail. Hydrogen is invisible to most telescopes, and in the frigid depths of interstellar space, such icebergs could theoretically form. The problem: no one's ever observed one, and hydrogen ice is notoriously fragile, likely vaporizing long before reaching our solar system. Then came the curveball, its shape. Most asteroids and comets are roughly spherical or lumpy, but Oumuamua's elongated form was bizarrely artificial looking. Coupled with its unexplained acceleration, some researchers, like Harvard astrophysicist Avi Loeb, suggested it might be light sail technology, an alien probe harnessing sunlight for propulsion. The idea wasn't pure fantasy. Humanity's own light sail projects like Breakthrough Starshot aim to send tiny craft to nearby stars using similar principles. Yet skeptics pushed back. If Oumuamua were artificial, why no radio signals? Why no obvious signs of construction? other natural explanations emerged. Perhaps it was a shard of a Pluto-like exoplanet, rich in nitrogen ice that vaporized stealthily. Or maybe a cosmic dust bunny, a fractal aggregate of interstellar debris so porous it reflected sunlight unevenly, creating the illusion of acceleration. The most haunting possibility we'll never know. Oumuamua is now beyond the reach of our telescopes, a fleeting enigma that left us more questions than answers. Was it a piece of alien technology, a cosmic oddity, or something beyond our current physics? Whatever the truth, this interstellar scout taught us one thing: the universe is far stranger than our textbooks dared to suggest. You'd think finding half the universe would be easy, but for decades, astronomers faced a cosmic accounting error so glaring it rewrote our understanding of ordinary matter. Here's the puzzle. When you tally up all the visible stars, galaxies, and gas clouds in the universe, you're left with only about half the normal matter called baryons that the Big Bang's equations insist must exist. It's like weighing a suitcase knowing you packed socks but finding only one of the pair. So where's the other half? The answer lies in the faintest, most elusive structures in existence: cosmic filaments. These aren't just any gas trails. Imagine the universe's largest spiderweb, stretching billions of light years between galaxies, woven from threads of superheated plasma so thin they're nearly transparent. This is the intergalactic medium, the final frontier for missing baryons. At millions of degrees, the gas is too hot to glow in visible light, yet too diffused to block background radiation. It's effectively invisible, but in the early 2000s, astronomers cracked part of the code. By studying how light from distant quasars filtered through these filaments, they detected subtle absorption lines, the fingerprints of ionized oxygen and hydrogen. This was the smoking gun, a reservoir of matter hiding in plain sight, woven into the fabric of spacetime itself. The hunt intensified with space telescopes like XMM Newton and Chandra, designed to spot X-rays emitted by the scorching gas. The breakthrough came when researchers realized these filaments weren't just passive backdrops, they were cosmic conveyor belts, funneling matter into galaxy clusters with gravitational currents. Simulations now suggest the missing baryons are split between these vast hot webs and cooler gas halos around galaxies, like steam hovering over a pot of cosmic soup. Yet the mystery isn't fully solved. Even accounting for these hidden reservoirs, there's a stubborn gap. About 30% of baryons remain unlocated. Some might lurk in even sparser regions or as faint, diffuse plasma ejected by galactic winds. Others could be tied up in exotic particles we've yet to detect. What's certain is this: the universe's ledger doesn't balance, and every new telescope, every deeper scan, brings us closer to finding where it stashed its ordinary treasure. The missing baryon problem isn't just a census error. It's a reminder that even the familiar stuff of stars and planets can vanish into the cosmic tapestry, waiting for the right tools to reveal its hiding places. Most cosmic explosions paint the sky with chaotic swirls of color, feral brushstrokes of gas and dust tossed into the void. Then there's the Red Rectangle Nebula, a cosmic masterpiece so precise it looks engineered. Floating about 2,300 light-years away in the constellation Monoceros, this isn't just another dying star's farewell. It's a geometric enigma, a near-perfect X-shape framed by luminous red rungs that give it the appearance of a celestial ladder. The strangest part: nature doesn't usually do symmetry. So how did this scarlet spectacle come to be? The secret lies in a dance of death between two stars. At the nebula's heart, a binary system, a dying red giant and its smaller, hotter companion spins in a tight, unstable orbit. As the red giant sheds its outer layers, the smaller star's gravity sculpts the ejected material into twin cones of gas, their bases pressed together like hourglasses. From Earth's vantage point, we see these cones edge on, their intersecting walls creating that startling X shape. The rungs, they're actually shock waves, ripples of dense gas pinched by the star's orbital motion, glowing crimson as they're bombarded by ultraviolet light. But geometry alone doesn't explain the red rectangle's fiery hue. The nebula's scarlet glow comes from an unlikely artist, carbon. Unlike most nebulas, which shine with the blues and greens of ionized oxygen or hydrogen, this one is drenched in complex organic molecules called polycyclic aromatic hydrocarbons, essentially soot. These carbon-rich compounds, forged in the red giant's atmosphere, fluoresce under stellar radiation like cosmic neon signs. It's a reminder that the building blocks of life aren't just earthbound, they're scattered across the galaxy, painted onto the canvas of dying stars. The real mystery isn't just how the red rectangle formed, but why we don't see more like it. Binary systems are common, yet this level of symmetry is staggeringly rare. Some astronomers suggest it's a fleeting phase, a cosmic alignment that lasts mere millennia before the nebula dissolves into chaos. Others speculate that the smaller stars' magnetic fields act like invisible guides, channeling the outflow into such crisp lines. Whatever the reason, the red rectangle stands as a testament to the universe's capacity for order amid chaos, a fleeting glimpse of precision in a cosmos that usually favors entropy. And when its central stars finally exhaust their fuel, this scarlet geometry will collapse into a gleaming diamond of crystallized carbon, a white dwarf wrapped in the ashes of its own artistry. Of all the wonders in our solar system, few are as hypnotically precise as the gargantuan hexagon spinning atop Saturn's north pole. This isn't some trick of perspective or camera artifact, it's a six-sided storm wider than two Earths, with razor-sharp edges that have persisted for at least 4 decades, maybe even centuries. Winds here scream at over 300 miles per hour, yet the structure remains eerily stable, a geometric freak of nature defying everything we know about planetary weather. How does a planet known for its elegant rings produce something so artificial-looking? The answer lies in a cosmic ballet of fluid dynamics. On Earth, storms spiral into familiar circular hurricanes governed by the Coriolis effect, the same force that twists bathtub drains. But Saturn, a gas giant with no solid surface, operates under extreme conditions. Its atmosphere is a layered chaos of hydrogen and helium, with jet streams moving at different speeds like interlocking conveyor belts. Back in 2010, researchers at the University of Oxford recreated this environment in a lab, spinning a 30-liter drum of water to simulate Saturn's polar winds. When they added a small ring at the center to mimic slower-moving polar air, something extraordinary happened. The fluid self-organized into polygonal shapes, including a near-perfect hexagon. The key, shear forces between fast outer currents and slower inner ones created standing waves that locked the turbulence into geometric patterns. But Saturn's version takes this to a mind-bending extreme. Data from NASA Cassini probe revealed that the hexagon isn't just skin-deep, it plunges at least 60 miles into the atmosphere, stacking hundreds of these wave patterns vertically like a honeycomb turned on its side. Even stranger, the hexagon changes color with Saturn's seasons, shifting from golden hues to eerie blues as sunlight waxes and wanes over its 30-year orbit. Some scientists suspect this kaleidoscope effect comes from ultraviolet radiation interacting with high-altitude haze particles, but no one knows for sure why the structure remains so stubbornly six-sided when other geometries are theoretically possible. Then there's the wildcard sound. In 2017, researchers proposed that the hexagon might be a physical manifestation of planetary-scale resonance, a vibrational note ringing through Saturn's atmosphere, much like how a plucked guitar string vibrates at specific frequencies. If true, it would mean the hexagon isn't just a storm but a sonic fingerprint, a cosmic chord frozen in gas. What makes this anomaly so mesmerizing isn't just its perfection, but its persistence. While Jupiter's great red spot shrinks and Earth's weather systems dissipate in days, Saturn's hexagon endures, a monument to the hidden order lurking within chaos. It's a reminder that even in the outer solar system where nature runs wild, there's room for precision and mysteries we've only begun to decode. Amid the swirling chaos of colliding galaxies and violent cosmic mergers, there exists a celestial oddity so perfectly structured it seems almost too pristine to be real. Hoag's object. Discovered by astronomer Arthur Hoag in 1950, this enigmatic ring galaxy floats 300 million light-years away, a cosmic bullseye with a golden core circled by a near-perfect ring of young blue stars, separated by a dark, almost empty gap. What makes it truly bizarre, most ring galaxies, like the famous cartwheel, form from violent collisions, one galaxy smashing through another, sending shockwaves that trigger star formation in a ring. But Hoag's object shows no signs of a disruptive past. No twisted debris, no second galaxy fleeing the scene. It's as if this cosmic jewel just appeared in its flawless form, defying the messy rules of galactic evolution. So how does such a symmetrical wonder exist? One theory points to a phenomenon called resonance. Imagine the galaxy's central core as a pebble dropped in a pond, sending ripples of density waves through its surrounding disk. Under just the right conditions, these waves could compress gas along a perfect circular path, igniting star formation in a precise ring while leaving the center untouched. It's the galactic equivalent of a skipping stone creating a single, flawless ripple. Another possibility involves a rare, slow-motion merger, a smaller galaxy spiraling into Hoag's object over billions of years, its gravity gently shepherding material into a ring without the usual cosmic fireworks. But here's the twist: Hoag's object might not be alone. Peering into the void behind it, astronomers spotted another faint ring galaxy, a potential sibling floating even farther away. This raises a tantalizing question. Could there be an entire family of these serene ringed anomalies, each born under conditions so delicate they avoid the chaos typical of galactic life? If so, they'd rewrite our understanding of how galaxies evolve without violence. The mystery deepens when you consider the gap. That dark void between the core and the ring isn't just empty, it's too empty. Normally, even in quiet galaxies, you'd expect some straggler stars or gas clouds. Yet here, the separation is almost surgical. Some researchers speculate that a rogue black hole might have cleared the area, or that the galaxy's magnetic fields acted like cosmic bouncers, ejecting material from the forbidden zone. What makes Hoag's object so mesmerizing isn't just its beauty, but its defiance. In a universe where galaxies grow by devouring each other, here's one that seems to have found a quieter path, a celestial Zen garden in a cosmos of demolition derbies. Whether it's a rare resonance miracle, a hidden merger's ghost, or something entirely unknown, this galactic oddity whispers a humbling truth. Sometimes the most profound mysteries wear the disguise of perfection. Buried within the faint glow of the cosmic microwave background, the oldest light in the universe, there's a patch of sky that just doesn't add up. Spanning nearly 2 billion light-years across, this so-called cold spot is a blistering anomaly, measuring 70 microkelvins colder than its surroundings. To put that in perspective, imagine the entire night sky as a warm blanket, except for one inexplicable chill the size of 60 full moons. At first glance, it might seem like statistical noise, a cosmic hiccup in the data. But the odds of such a cold region forming randomly, less than 2%. So what's really lurking in this frigid void? One spine-tingling possibility is that we're staring at the imprint of another universe. In certain multiverse theories, when our universe bubbled into existence during the Big Bang, it might have brushed against a neighboring cosmos. That collision could have siphoned energy away from this region, leaving behind a telltale cold signature, like a cosmic bruise from a long-averse encounter. It's a radical idea, but not without precedent. Quantum physics suggests that parallel universes could exist as part of a vast multiverse, each with its own laws of physics. If true, the cold spot might be our first tangible evidence that we're not alone in the greater cosmic foam. But before we jump to interdimensional conclusions, there's another equally mind-bending explanation: cosmic textures. Picture the early universe as a bubbling pot of primordial energy. As it cooled, cracks might have formed in the fabric of space-time, defects analogous to ice crystals forming in water. These textures would warp gravity around them, creating voids where matter is repelled instead of clustered. If such a texture collapsed near the cold spot's location billions of years ago, it could have left behind this eerie, energy-depleted region. The plot thickens when you peer into the cold spot with optical telescopes. Instead of finding a vast emptiness, astronomers have detected a bizarre supervoid, a sparse region with 20% fewer galaxies than expected. But here's the catch: even this underdensity can't fully account for the cold spot's temperature drop. The numbers don't add up. Some researchers argue that the supervoid and the cold spot are unrelated, their alignment a cosmic coincidence. Others propose that the void's gravity distorts passing CMB photons in a process called the integrated Sachs-Wolf effect, sapping their energy over billions of years. What makes this anomaly so tantalizing is that it refuses to fit neatly into any one box. Is it a window into the multiverse, a fossil of exotic physics? Or just an unlucky statistical fluke that's fooling us all? Future telescopes, like the European Space Agency's Euclid mission, could settle the debate by mapping the distribution of dark matter around the cold spot. If the void runs deeper than visible matter suggests, it might hint at forces beyond our current understanding. Until then, this frigid enigma remains one of cosmology's most compelling open cases, a mystery written in the universe's first light, waiting for us to decode its secrets. In 2020, astronomers scanning the sky with radio telescopes stumbled upon something so bizarre. It didn't fit any known category of cosmic objects: massive, ghostly rings glowing in radio waves, each spanning hundreds of thousands of light years. They called them odd radio circles, or ORC, and to this day no one knows exactly what they are. These enigmatic structures don't emit visible light, X-rays, or any other detectable radiation, just faint, diffuse radio signals forming near-perfect loops in the void. The strangest part, they're only visible in radio wavelengths, invisible to every other type of telescope, like cosmic fingerprints that only show up under one special light. One leading theory suggests ORCs might be the aftermath of a colossal explosion, perhaps a shockwave from a supermassive black hole's feeding frenzy, blasting out jets so powerful they ripple through intergalactic gas like a stone dropped in a pond. Imagine a black hole devouring a galaxy's worth of material, then belching out energy in opposite directions, leaving behind these gargantuan rings as cosmic echoes. Supporting this idea, some ORCs appear centered on galaxies with active black holes, their symmetrical shapes hinting at an eruption too vast to comprehend. But here's where it gets weirder. Not all ORCs have obvious galactic anchors. Some float in seemingly empty space, untethered to any visible source. This has sparked even wilder explanations, like the remnants of a stellar superwind, a hypothetical hurricane of stars forming and dying so violently that their combined explosions create a spherical shockwave. Or perhaps they're the scars of ancient cosmic strings, theoretical defects in space-time left over from the Big Bang, vibrating like guitar strings and rippling the fabric of reality itself. Then there's the timing. ORCs seem to be phenomenally rare, with only a handful detected so far, all at similar distances from Earth. This suggests they might represent a fleeting phase in the universe's life, something that only occurs under very specific, short-lived conditions. Are we catching these cosmic smoke rings just as they blossom, only for them to fade into the dark moments later? The most tantalizing possibility: ORCs could be a sign of something entirely new, a class of object or interaction we've never imagined. Every time we think we've catalogued the universe's quirks, it throws another curveball, reminding us how much lies beyond the edge of our understanding. For now, these ghostly circles remain one of astronomy's freshest puzzles, glowing faintly in the radio silence, daring us to decode their secrets. Deep in the cosmos, some stars refuse to die gracefully. Instead of fading into oblivion or exploding in a final, spectacular supernova, they lurch back from the brink stellar zombies, feeding off companions or reigniting from their own ashes. Among the most famous is Tycho's supernova remnant, named after the 16th century astronomer Tycho Brahe, who witnessed its sudden appearance in 1572. For weeks, it shone brighter than Jupiter, visible even in daylight before vanishing from the naked eye sky. Yet today, 4 centuries later, X-ray telescopes reveal something bizarre. A smoldering husk still crackling with energy, as if the star's death throes were never truly finished. These cosmic undead challenge everything we know about stellar life cycles. Normally, when a white dwarf, the dense core of a dead star, siphons too much mass from a companion, it hits a critical limit and detonates in a Type Ia supernova, obliterating itself completely. But Tycho's remnant hints at a stranger fate. Spectroscopic data shows clumps of unburned material deep in the wreckage, suggesting the explosion was uneven, even hesitant. It's as if the star tried to die and failed, leaving behind a mangled corpse still hot enough to glow in X-rays. Then there's the even weirder breed of zombie stars, the vampire binaries. Picture a white dwarf locked in a gravitational tango with a living star, slowly draining its lifeblood hydrogen gas. Most of the time, this stolen fuel ignites in periodic nova outbursts, bright enough to outshine entire galaxies for days. But in rare cases, the vampire star doesn't just sip, it gorges. Systems like Rs Ophiuchi have erupted multiple times in recorded history, each outburst leaving the white dwarf intact, ready to feed again. Like cosmic Draculas, these stars cheat death by feeding off their neighbors, resetting their doomsday clock with every stolen breath of stellar plasma. The most unsettling cases are the failed supernova. In 2015, astronomers watched in disbelief as a red giant star 22 million light-years away simply dimmed. Instead of erupting into a supernova, it collapsed directly into a black hole, swallowing its own explosion whole. Only a faint infrared glow betrayed its fate, a cosmic burp where a fireworks display should have been. It's a reminder that even stars in their final moments can defy expectations, leaving behind ghosts that lurk in the data, waiting to upend our models of stellar mortality. What makes these celestial undead so fascinating isn't just their defiance of astrophysics textbooks, it's the clues they offer about the universe's most violent events. Partial explosions like Tycho's might explain why some supernova produce less iron than predicted, while vampire systems could be the ticking time bombs behind history's guest stars, those mysterious celestial flares once interpreted as omens. Every zombie star we find forces us to reconsider the boundaries between life and death in the cosmos, proving that even in the cold vastness of space, survival takes on forms more bizarre than fiction could invent. At the farthest edges of our cosmic maps, something impossible is happening. Entire clusters of galaxies are streaming toward a point beyond the horizon of the known universe, as if tugged by an unseen hand. Astronomers call this the dark flow, a mysterious river of galaxies moving in unison at speeds over 2 million miles per hour toward a void we can't see. It's not the expansion of space pulling them apart, nor the gravity of any known structure. This is something else entirely, a current in the cosmic ocean flowing toward an unknown destination. The discovery came in 2008 when scientists studying the cosmic microwave background noticed something unsettling. Galaxy clusters weren't just drifting randomly with the universe's expansion. They showed a preferred direction, like iron filings drawn to a magnet outside the frame. The scale was staggering. This motion encompassed over 1,400 clusters stretching billions of light-years across. The most unnerving part, the source of this gravitational pull, lies beyond the observable universe, in a region of space-time we'll never see, even with the most powerful telescopes. One spine-tingling explanation points to the multiverse. If our universe is just one bubble in an infinite froth of others, it's possible that a neighboring cosmos, with its own gravity, is close enough to tug on our galaxies from beyond the cosmic horizon. Picture two soap bubbles barely touching. Even without popping the barrier between them, the surface tension of one could deform the other. Similarly, a nearby universe's mass might be warping space-time just enough to set our galaxy clusters adrift in its direction. But there's another, equally mind-bending possibility: cosmic defects. In the early universe, as space-time cooled from the searing heat of the Big Bang, cracks might have formed in its fabric, like ice splintering as it freezes. These hypothetical structures, called domain walls or textures, could exert gravitational influence on scales larger than superclusters, acting as invisible slopes down which galaxies slide. Some models suggest such defects could explain the dark flow without invoking other universes, though their existence remains purely theoretical. Skeptics argue the dark flow might be an illusion, a statistical fluke, or a subtle error in how we measure galaxy motions. Yet the signal persists across multiple studies, even as detection methods improve. If real, its implications are profound. Either our universe is being pulled by something unimaginably vast beyond its borders, or the cosmos harbors structures so strange they rewrite our understanding of gravity itself. The dark flow isn't just a mystery, it's a signpost pointing to realms we may never reach, but whose presence we feel in the quiet drift of galaxies toward the unknown. Hidden in the constellation Monoceros, Latin for unicorn, astronomers have found a celestial oddity that shouldn't exist: the smallest black hole ever detected, weighing just 3 times the mass of our Sun. Dubbed the unicorn, this cosmic runt defies everything we thought we knew about how black holes form, squeezing itself into a theoretical no-man's land called the mass gap. For decades, scientists believed black holes couldn't possibly exist this small, or this sneaky. The unicorn wasn't discovered by spotting its telltale glow of infalling matter or the warped light of its event horizon. Instead, researchers caught its gravitational fingerprint, the subtle wobble of a nearby red giant star being tugged by an unseen companion. Like a dancer pulled off balance by an invisible partner, the star's rhythmic dimming and velocity shifts betrayed the black hole's presence. Most black holes in this size range should have evaporated long ago or collapsed into neutron stars, yet here it was, lurking quietly in our galactic backyard, barely 2,000 light-years away. This discovery cracks open a long-standing puzzle in astrophysics, the mass gap problem. Neutron stars, the densest stellar corpses, top out at around 2.1 solar masses before collapsing under their own gravity. Black holes, on the other hand, were thought to form only above 5 solar masses, leaving a perplexing void in between. The unicorn bridges that gap, forcing scientists to rethink the death throes of massive stars. Could some stellar collapses produce failed black holes, objects too heavy to stay neutron stars but too light to fit traditional models? One theory suggests the unicorn might be the stripped core of a once larger star, its outer layers siphoned off by a companion long ago. Another posits that exotic quantum effects could stabilize black holes at these improbable sizes, like cosmic origami folding matter into tighter configurations than physics should allow. Whatever the explanation, this tiny titan proves that even the darkest objects in the universe still have surprises to reveal, and that sometimes the rarest cosmic creatures hide in plain sight. Wrapped in perpetual twilight, a world gleams with unearthly fire, not from molten rock but from something far more exotic. 55 Cancri, a planet twice Earth's width orbiting perilously close to its star, isn't just another scorched super-Earth. This is a cosmic jewel box, a planet where mountains might literally be made of diamond and rivers could flow with molten graphite. Discovered in 2004, this 40-light-year oddity defies all expectations of planetary chemistry, forcing us to rewrite the recipe for how worlds are born. The secret lies in starlight. Unlike our Sun, 55 Cancri is a carbon-rich star forged from a nebula laced with soot and diamonds. When planets formed around it, they gorged on carbon instead of silicon and oxygen, the building blocks of Earth's rocky crust. The result, a super-Earth where up to a third of its mass could be crystalline carbon. Picture continents of diamond icebergs floating on seas of liquid carbide beneath skies thick with hydrocarbon haze. At surface temperatures nearing 2,000 degrees Celsius, the very air might rain tar, a far cry from the water clouds of our blue marble. Yet the real mystery isn't the bling, it's how such a planet survives its own hellish orbit. Circling its star every 18 hours, 55 Cancri E is tidally locked, one face forever scorched while the other languishes in eternal night. Early observations suggested lava oceans, but newer data reveals something stranger. Extreme temperature swings with no clear volcanic explanation. Some researchers now propose that the planet's carbon crust acts like a cosmic heat sponge, conducting and radiating thermal energy in ways no silicate rock could, creating diamond-driven weather patterns we've yet to comprehend. The most tantalizing question, could carbon planets host life? In Earth's crust, carbon is life's backbone, but here, it's the entire stage. Astrobiologists speculate that in cooler regions of such worlds, carbon chemistry might brew exotic precursors to biology, using liquid metals or supercritical carbon dioxide as solvents instead of water. Imagine organisms with structural frames of graphene, metabolizing acetylene instead of glucose, a shadow biosphere where diamonds are the new dirt. But 55 Cancri E isn't alone. Recent surveys suggest 1% of Sun-like stars might host carbon-rich planets, each a laboratory for alien geology. Some could be diamond havens like this one, others graphite wastelands, or even the long-theorized carbide worlds where the crust reacts violently with water to form acetylene gas. Each discovery peels back another layer of planetary diversity, proving the cosmos has more flavors of worlds than we ever dreamed. And glittering at the heart of it all, this diamond super-Earth reminds us, sometimes the universe's most valuable treasures aren't hidden, they're hiding in plain sight, masquerading as impossible planets. Astronomers peering back to the universe's infancy have stumbled upon a paradox that rewrites galactic history pristine. Fully formed disk galaxies gleaming in the darkness just 1.5 billion years after the Big Bang. These cosmic frisbees shouldn't exist, not yet. Not when prevailing models insist the early universe was a demolition derby of chaotic collisions, where galaxies grew through violent mergers into messy, lumpy shapes before settling into orderly spirals like our Milky Way. Yet there they are, captured by the James Webb Space Telescope, delicate, rotating disks with symmetrical arms, their stars already orbiting in serene harmony, as if billions of years of cosmic evolution never happened. The discovery throws a wrench into everything we thought we knew about galactic growth. Picture trying to assemble a Swiss watch by tossing its parts into a blender. That's how theorists imagined early galaxy formation. Gas clouds should have clumped together randomly, stirred by the gravitational pull of dark matter halos, crashing and tangling until turbulence settled into structure. Yet these primordial disks are impossibly calm, their stars moving in coordinated planes like a well-rehearsed ballet. One such galaxy, the evocatively named Wolf Disk, spins at a staggering 272 kilometers per second, nearly matching our Milky Way's rotation, despite being born when the universe was just 10% of its current age. So how did these celestial orderlies emerge from the primordial chaos? One radical theory suggests early galaxies had a secret ingredient, cold gas streams. Unlike the hot, violent accretion models, These filaments could have funneled pristine hydrogen directly into forming disks with minimal turbulence, like gentle rivers smoothing sand into perfect circles. Simulations show that under just the right conditions, specific densities, angular momentum, and dark matter distributions, disks might snap into place almost instantly, skipping the expected billion-year phase of cosmic bumper cars. But there's a catch. These serene disks exist alongside the expected train wrecks of the early universe, meaning both formation paths might somehow coexist. Some researchers speculate that the calmest galaxies formed in rare, quiet neighborhoods of the cosmos regions where dark matter was distributed just right to cradle rather than disrupt. Others propose that supermassive black holes acted as cosmic anchors, their gravity stabilizing swirling gas before it could collapse into chaos, the most mind-bending possibility. That dark matter itself behaves differently in the early universe, with properties that allowed these structures to assemble faster than physics currently allows. What makes this anomaly so thrilling isn't just its defiance of textbooks, it's the way it mirrors modern observations closer to home. The Milky Way's own disk shows signs of ancient stability, with stars nearly as old as the universe itself orbiting in eerily perfect planes. Could our galaxy have been one of these early overachievers, a relic of a forgotten era when the universe somehow crafted perfection from the storm? Every new disk galaxy discovered in the deep past forces us to reconsider the timeline of cosmic structure, hinting that the universe might have more than one recipe for building islands of stars. And with each revelation, we're left to wonder how many more cosmic rule books are waiting to be rewritten. The Big Bang was supposed to be the ultimate cosmic alchemist, transforming energy into matter with mathematical precision, forging the lightest elements in exact quantities we could calculate. Hydrogen, helium, even traces of deuterium and helium-3 all match our predictions beautifully, but there's one glaring exception, an element that refuses to fit the cosmic ledger: lithium. According to the equations, the newborn universe should have produced 3 times more lithium-7 than what we actually observe in ancient stars. This isn't just a minor accounting error. It's a fundamental crack in our understanding of nucleosynthesis, the very recipe by which the universe cooked its first atoms. So where did all the lithium go? One possibility is that stars destroyed it. Ancient stellar furnaces, known as population 3 stars, might have been far hotter and more turbulent than we thought, burning through primordial lithium like kindling. Picture these first-generation stars, monstrous behemoths hundreds of times the mass of our Sun, swallowing the fragile element and fusing it into heavier elements before it could escape into the cosmos. Alternatively, lithium could have been shredded by cosmic rays in the chaotic early universe. Its atoms shattered into smaller particles before they could accumulate in measurable amounts. But here's where it gets stranger. Some astronomers argue the problem isn't missing lithium, it's flawed physics. The Big Bang nucleosynthesis models rely on precise nuclear reaction rates, and if even one of those rates is slightly off, the entire lithium prediction crumbles. Experiments with particle accelerators suggest that certain nuclear interactions involving beryllium-7, a key stepping stone in lithium's formation, might have been miscalculated. A tiny adjustment here could solve the discrepancy, but it would mean rewriting part of the universe's instruction manual. Then there's the wild card: exotic early universe physics. Could unknown particles or forces have altered how lithium formed? Some theorists propose that dark matter interactions in the primordial plasma might have disrupted nucleosynthesis, while others speculate about variations in fundamental constants during the universe's first seconds. These ideas border on the radical, but when standard models fail, the cosmos often pushes us toward the unimaginable. What makes the lithium problem so fascinating isn't just the missing atoms. It's the reminder that even our most rigorous cosmic blueprints might still be rough drafts. Every ancient star we scrutinize, every lab experiment refining nuclear rates, brings us closer to understanding whether the error lies in our telescopes, our equations, or the universe's own hidden rules. And until we solve it, this quiet anomaly will keep whispering that the Big Bang story isn't quite finished. From the eerie whispers of the wow signal to the ghostly grip of dark matter's invisible hand, these 25 cosmic anomalies aren't just curiosities, they're the universe's way of nudging us off balance, reminding us how much we still don't know. Think about it, every time an observation defies explanation, like the perfect symmetry of Hoag's object or the chilling void of the Boötes void, it's not a failure of science, it's an invitation. A call to dig deeper, to question assumptions, and to rewrite the rules we thought were set in stone. That's the thrill of astronomy. The moment you think you've got it all figured out, the cosmos throws a curveball, whether it's a diamond planet where it shouldn't exist or a galactic hexagon spinning with impossible precision. And here's the beautiful part, these mysteries aren't dead ends, they're starting points. The missing lithium problem forces us to revisit the Big Bang's recipe book. The dark flow hints at realms beyond our cosmic horizon. Even the humble pioneer anomaly, solved by something as mundane as heat, taught us to measure the heavens with sharper eyes. Every anomaly is a thread in a grander tapestry waiting to be pulled. Who knows what will unravel next? Maybe the James Webb Telescope will spot another primordial disk galaxy, upending our timeline of cosmic evolution. Or perhaps a new radio burst will crack the code of FRBs, revealing messages, or just physics we've yet to imagine. So stay curious, the universe isn't done surprising us. Whether you're team alien megastructures for Tabby's star or convinced the axis of evil is just a statistical fluke, the conversation itself is what moves us forward. Drop your wildest theories in the comments. After all, some of history's biggest breakthroughs began as someone's crazy idea. And remember, the next time you look up at the night sky, you're not just staring at points of light. You're gazing at a frontier, one where the answers we have are outnumbered by the wonders we've yet to discover. The cosmos is writing its story in riddles, and we're only just learning how to read.